Hi everyone, myself Jehrin J, MSc Biology, St. Mary's College, Thrissur. Today we are going to discuss about dialysis precipitation method and application. Let's see in detail. Dialysis. Dialysis is a common laboratory technique that operates on the same principle as medical dialysis. In context of life science research, the most common application of dialysis is for the removal of unwanted small molecules such as salts, reducing agents or dyes from the larger molecules such as protein, DNA or polysaccharides. Dialysis is also commonly used for buffer exchange and drug binding studies. Precipitation and dialysis. Precipitation and dialysis are used to purify glomalin lyophilization, freeze drying and storage. This also helps to purify and concentrate the protein for subsequent analysis. Protein concentration should be at least 5 mg or freezing dried amount will be rather small and difficult to measure accurately. Different chemicals used to precipitate and reconstitute glomalin, which may be dialysed agent, a dilute buffer solution or water. Like other proteins, glomalin will precipitate in high ionic, that is salt solutions such as NH4SO4. Glomalin is insoluble in acid solution and will precipitate in HCl at pH 2.0 to 2.5. In addition, glomalin may be reconstituted in many alkaline solutions such as NaOH for dialysis. There are mainly two types of dialysis, diffusion dialysis and electrolysis. Diffusion dialysis. The main advantage of diffusion dialysis is the low energy consumption of the unit. Membrane technique operates under normal pressure and does not have a state change. The energy required is significantly reduced, which reduces the operating cost. There is also the low installation cost, easy operation and stability and reliability of the process. Another advantage is that diffusion dialysis does not pollute the environment. The disadvantage of diffusion dialysis is a diffusion dialyzer has a low processing capability and low processing efficiency. There are other methods such as electrodialysis and reverse osmosis that can achieve better efficiencies than diffusion dialysis. Next we will discuss about electrodialysis. The main benefit of electrodialysis is high recovery and water recovery. Another advantage is that it does not require high pressure is applied, which implies that effect fouling is not significant and consequently no chemicals are required to fight against them. The fouling layer is not compact, which lead to higher recovery and to a long membrane life. It is also important that the treatment are for the concentration higher than 70,000 ppm, eliminating the concentration limit. The energy required to operate is low due to the non-phase change is in comparison with the needed in multi-effect distillation, that is MED, and mechanical vapor compression MVC process. The main drawback of electrodialysis is the current density limit. The process must be operated at a lower current density than the maximum allowed. Fact that certain voltage applied the diffusion of ion through the membrane are not linear, leading to water dissociation. It would reduce the efficiency of the operation. Another aspect to take it into the account is that although low energy is required to operate, the higher the salt feed concentration is, higher the energy needed will be. In case of some product, it must be considered that electrodialysis does not move microorganisms and organic contaminants, therefore a post-treatment is necessary. Applications of dialysis can be divided into two categories based on their type. So application is also will be differ. Diffusion dialysis. Some application of diffusion dialysis is the strong aqueous caustic soda solution can be purified of hemicellulose by diffusion dialysis, specific to largely obsolete viscose process. First step is that the process is to treat almost pure cellulose, that is cotton linter dissolving pulp with strong solution of sodium hydroxide, that is caustic soda, in water. One effect of the step is dissolve the hemicellulose. In some circumstances, it is desirable to remove as much hemicellulose as possible out of the process, and that can be done using dialysis. Acids can be recovered from an aqueous solution using anion exchange membrane. The process and alternative treatment of the industrial wastewater. It is used for the recovery of of mixed acid and the recovery and concentration of Zn and Cu and H2SO4 plus ZnSO4 and the recovery of H2SO4 from the waste sulfuric acid solution containing FeNi ions which are produced at the diamond manufacturing. Dealkalization of PEER is another application of diffusion dialysis. Electrodialysis. Applications of electrodialysis consist of the desalination of whey, deacidification of fruit juice, desaltization of soy sauce, separation of amino acid into acidic, basic and neutral groups. Some applications of electrodialysis are explained. Let's explain in detail. Is the desalination of whey is a large area used for this type of dialysis in the food industry. It is necessary to remove the crude cheese whey containing calcium, phosphorus, other inorganic salt to produce different foods such as cake, bread, ice cream, baby foods, etc. Deacidification of fruit juice such as grape, orange, apple and lemon are processed in which electrodialysis is applied. An anion exchange membrane is employed in this technique, implying that citrate ions from the juice were extracted and replaced by hydroxide ions. Desalting of soy sauce. The conventional value of salt in brewing soy sauce are cost 16 to 18%, which is equate high content. Electrodialysis is used to reduce the amount of salt present in soy sauce. Nowadays, diet of low salt content are very present in society. Separation of amino acids into acidic, basic and neutral group. Specifically, cytoplasmic leaf protein are extracted from the alpha leaves. Applying electrodialysis. When proteins are denatured, the solution can be desalted and acidified with high H+ ions.